So, hi class. Or if you're here, that means at least you paid attention to my announcement in the Canvas. Congratulations. Um, so I'm going to try to cover some of the content um, while I'm traveling for the week of September 17th. I feel a little bit weird because by talking to the blank screen, but let's try. So a couple of announcements. I don't think I've sent out, well, I will send out announcements about my traveling, about this video URL, but right now the only thing I want to cover is there will be, two smaller homework by putting together one big homework that are going to be released today, and it will be due next week and the week after, so you will have time to finish them. Now let's review what we learned last section, or session rather. So we did a little demo of assembly code. We have a main C file that does some UI for us, get to input of integers, and then we call it assembly code and do our operations and print out the results. Here's a quick review of register binding. The important ones are circled in red circles. For a function call, the input arguments, if they're less than 4 or equals 4, they're put into A0 to A3. And the register number from 4 to 7. Return value of the function call is put into these two registers. For C functions, there's only one register we use here, and there's another one important is function return address is put into this 31 register. So let's see, with this we can start to write a simple assembly code. I'm not going to repeat, but the key thing code are here, and we just do a simple add, put into the return register, and then we jump the return register and return. So we did an experiment on that, and we're using a shortcut to compile and to run, and also we used object dump with -d option to by the way, -d stands disassemble. Disassemble this object file, and then we can actually see what is the instruction encoding in the memory. And then we did verify it's indeed an add instruction, which is what we expected. Then we moved on to talk a little bit more logical operations, including shifting and or and not. So shift, there's a logical shift, is shift to the left or shift to the right. It's called logic because after dropping the leading, if shifting to the right, you drop the last bits, but you prepend it with 0, and it became like this, and left. So it's equivalent to divided by 2, and shifted to the left is equivalent to multiplied by 2. Oh, I got those two reversed. Sorry about that. There's also corresponding shift to the right arithmetically. The difference is the leading bit is not always 0. It just take a copy of what it is. So it's important for a negative number remains negative this way. We also talk about a special instruction. So one way you remember it's special is because its value is all 0. It's all 0. So that's why I make it so special. But if you really decode it, it's turned out to be a function instruction, a logical shift to the left with 0 registers and shifting 0 bits. So, essentially it does nothing. So that's exactly what this one is. And then we talk about AND. which is a 3-register for R format instruction. It just do a bitwise AND put into the destination register. So here you can see if both bits are 1, the AND result is 1. But if one of them is 0, the AND is 0. Same thing with OR. And for NOT, there is no NOT instruction in MIPS, but there's a NOR, not OR instructions. It's essentially just like OR, but you perform a negation at the end. So with that, and if we use one of the registers to be 0, we essentially can perform NOT operations. So there are a little bit more forms of these instructions, including you can do an immediate form of that. And there's also original, not OR form with the immediate form. Now I have to pause the video right now because I don't know if I can switch window. I don't think I can switch the window. I'm going to do an experiment, so just bear with me for a few seconds. Let's see if I switch to window. Is this working? Now I want to show you there is a excellent MIPS reference page here. I want to see if we can check an immediate format. Basically what it says, you do a bitwise AND register and an immediate value store. I want to check, because immediate value only 16 bits, what happens to the left upper 16 bit, but it doesn't say. Okay, I'm going to pause now.